All right, so now that we've gone through some of the things about quadratic equations and solving these, what we're going to get into now is something called complex numbers. And all numbers are complex numbers, and yeah, okay. And after this, we'll be moving on, and you'll be able to do some cool things with complex and imaginary numbers. So the first thing here is imaginary numbers, and what imaginary numbers are not real numbers. So if you try to take the square root of a negative number, two numbers multiplied together gets you a negative number. Well, that's not possible. Whenever you multiply two negative numbers together, they're always positive. If you multiply two positive numbers together, it's always positive. So if we try to take the square root of a negative number, what do we get? Well, it's not a real number. It's an imaginary number. Okay? And to denote the imaginary number, it's I. Okay? And the way that we've identified these is by using complex numbers. Okay, and so this little cartoon with Calvin and Hobbes, obviously 11 and 3012, those aren't actual numbers, but we're going to be talking about actual imaginary numbers and complex numbers. And so if you have something like the square root of 64, negative 64, whenever you have a negative, okay, automatically you take an I out. And then whatever is on the inside, you take the square root of that. So the square root of 64 is 8, so you would say it would be 8i. Okay, so that is the square root of negative 64. Now the next one, square root of a negative 8. Okay, well, you take the I out. If you break 8 down, it would be 2 and 4, and then 2 and 2. 2's come out, leaving you with 2i root 2, because you have one left over. And that would be your simplified form. But as you see, whenever you have that negative underneath the radical, you're going to keep an I. It's going to be I square root something or something I. It's an imaginary number because it's not real. Right, now, all imaginary numbers and real numbers can be written as complex numbers. So any number you can think of, imaginary or real, can be written as a complex number. The first part, the blue or the red part, is the real part. So this is the number that is an actual number that we see all the time. So if I were to say 8 plus 4i, okay, the 8 is the real number, and then the 4i is the imaginary part, okay. So if, let's say I just have the number 41, okay, my personally favorite number. 41 can be written as a complex number because it's 41 plus 0i. Okay. So as you see, you can still write it as a complex number even though it is all real. And now if you go the other way, if you have like 4i, okay, that can be written as 0 plus 4i. And that would be written in the complex form where you have no real part and the rest is imaginary. Now, cool thing about these is that you can graph imaginary numbers and complex numbers. Okay. And what you'll do is that where the x coordinate usually is, that's your real, and then the y is your imaginary. And what it is, so like if this one here, where I've got 8, 4i. So on the real, I'll go to 8. 1, 2, 3, 4, 5, 6, 7, 8. And on the imaginary, I go to 4. 1, 2, 3, 4. And then I put a dot there. And what you'll do is that you'll draw a vector from the origin to that point. And that's the direction in which it is going off into space. Okay, so if you want to think of this as like real, if you have a just like a blank sheet, okay, that's all real numbers. And now if we want to put it into another dimension, so we want to put it into a higher dimension, and we bring it up, and we want to go, and we want to pull it off the page and put it up in space. That is where your imaginary part comes into play. And that's kind of a way of thinking it about these imaginary and complex numbers. So they're not on the sheet, they're above it and floating out in space. All right, so imaginary numbers. So one thing with imaginary numbers is that when you take them to a power, okay, you get, they kind of reduce down. And so it's I to the first is I to the second is -1, I to the third is -I, and I to the fourth is 1. Okay, and this is by taking, if you have square root -1, which is what I is, you multiply that by square root -1. That gets you -1. Then you multiply that by square root -1, gets you a -I, and then you multiply this by square root negative 1, gets you a 1. A way to help you remember this is by going I1, I1. Okay. So by saying I1, I1, it helps you, it's a little memory trick to help you remember, okay, it's I, then it's 1, and then it's I, and then it's 1. Okay. So if I have I to the 11th, well, I to the 11th can be written as I4 times I4 times I3. And I4 is 1, I4 is 1, I3 is negative I. So this, I to the 11th, would reduce down to negative 1. And that would be the simplified form of I to the 11th. So if I were to take I to the 22nd, let's say, I to the 22nd, how many groups of 4 can I make? Well, I can make 5 of them. And then how many do I have left over? I2, which would get me a negative 1. So this reduced gets you negative 1. Okay. And a way to do this is that you take whatever the power is, divide it by 4, and what you're looking at is the decimal part, or the remainders, if you want to keep it in remainder. This would be 5 remainder 2. That is the power you're doing. So it would be a remainder 2, or I to the second power, which is negative 1. Okay. So simplifying these, 54 divided by 4 would get you 1, 3, remainder 2. So it looks like you'll have I squared, which would be negative 1. 123 divided by 4 gets you 30 remainder 3. So I3, which is a negative I. And then the last one, 4 times 7, 28. I times I squared, which would get you 28 times negative 1, which is negative 28. So whenever you have these, you're going to treat I as if it was just like a variable. Okay. You can add them together. You can subtract them, with other i's, as long as they have the same power. All right, so your I right here, simplify square root of a negative 125, simplify it to its most simple form, and then combine like terms for this one, and then multiply the I, 4i into there. Okay, so simplify those and get your answers for those. And that is your IRAT for complex numbers.